Hello, our esteemed viewers. You're welcome once again to your favorite mathematics YouTube channel, Mathematics by Zainab, a channel especially created for you and I to demystify mathematics and tackle the age-long phobia associated with this subject, one topic at a time. Today promises to be very interesting as well, as we delve deeper into the topic inequality. This time around, we're looking at the concept of range of values in inequality. When you see range of values in inequality, it simply means an expression A less than X less than B, where usually A is lesser in value than B. In terms of number line, it's written this way. If you have A here and you have B here, so that means X is anywhere between A and B. And in this case, you can have this. For strictly A less than X less than B. However, if you have A less than or equal to X less than or equal to B, this simply means A and B are inclusive in this case. So you're going to have something like this, shaded. That is the difference between the first statement and the second. If on the other hand we have A less than or equal to X less than B, it simply means we are shading the A side and leaving the B side unshaded. And lastly, if you have A less than X less or equal to B, we're going to have something like this. Only the B side is going to be shaded, whereas A will not be shaded. These are the possible scenarios. However, there are other exceptional cases whereby we have them this way. We have A here and have B here, and have something like this. That means it's not possible to express in this format. It's still range of values. However, it can be written as a merged form. So let's delve into today's lesson by looking at the possible scenarios you have using the two examples on the board. Question 1 says, we should find the range of values of X that satisfy this inequality. We have 1 less than 2X plus 1 less than 9. This actually is 2 in one statement. So we're going to break it down into the two distinct statements. The first one is to say that 1 less than 2X plus 1. We neglect the other part, which is less than 9. Hence, we solve this normally, which is 1 minus 1 less than 2X. 1 minus 1 is 0 less than 2X. Therefore, 0 over 2 less than X. Hence, 0 is less than X. That is one way of it. The second part this time around, we also similarly neglect the left part and go with 2x plus 1 less than 9, which means 2x less than 9 minus 1. So 2x is less than 8. Therefore, x less than 8 over 2, which is 4. So we now merge these two solutions, leaving us with 0 less than x on one hand, than x less than 4 on the other hand, and that is the answer. So if you are to draw this on the number line, you're going to have 0 and 4, both unshaded, 0, 4, because we have simply less than, no equality sign. And that is the solution to question number 1, which I believe is quite straightforward. What you need to do is to break the merged statement into two separate parts and solve them individually and possibly see if we can fuse them. Okay, let's take number 2. Question number 2 is pretty much the same as this. We have x less than 3x plus 2 less than 2x plus 6. So the first statement is x less than 3x plus 2. We ignore the other side and solve this. So this means x minus 3x less than 2. And this is minus 2x less than 2. Remember, when we divide by negative sign, this symbol changes. So we have x is greater than 2 over minus 2, meaning x is greater than minus 1. Of course, this can also be written as minus 1 less than x. It's equivalent. X greater than minus 1 also means minus 1 is actually less than x. So that's the end of that wing of the solution. The other wing, we have 3x plus 2 less than 2x plus 6. So we have 3x minus 2x less than 6 minus 2. And that's simply x less than 4. And we're done with that. So we now see if we can match these two. So we have on the first side, we have minus 1 less than x, and x in turn less than 4, which is very agreeable. Because I said from the beginning that the proviso is that the very first number here, which is a, must be less than the second number. So we come to the end of the solutions of the two examples to explain the concept of range of values. This is by no means exhaustive. However, the more you lay your hand on questions, the more you see some challenging and interesting questions indeed. So with that, I leave you to ponder on this. I believe you find today's class quite interesting and quite fun as well. As I also always say, math is fun. It's about mindset, the determination, and the belief in yourself. Because if you don't believe in yourself, who will? So, I always urge you as usual to please subscribe, share, and tune in your notification bell so that you'll be the first to know when we drop our next video. God willing. Stay tuned and God bless.